Hello, can you still hear me?
Yes, sir.
You still see me?
Yes, sir.
All right, share my screen.
All right, throw that slide up and I will do the introduction. Hello, everyone, and welcome to Improving Talks. If it's your first time here, welcome. If it's your returning, thank you for coming back. Before we get started, I would like to point out in the bottom center of your screen, you will see a Q&A. That's where you can put in your questions. Mark has requested that I hold questions to the end, so I will help prompt him at that time. So today we have Mark Soul talking about Neo4j and ORMs in modern software development, and I will let you take it away, Mark.
All right, thank you. Hello, everyone. My name is Mark Soul. I'm here to give this presentation. Oops, sorry about that. I'm a senior consultant with Improving, and I've been here for almost 3 years now. Minnesota born and raised. I'm interested mainly in back-end technologies, distributed systems, anything in the cloud. I like digging into like really deep topics like this and figuring out how we would use this knowledge to build really fun, interesting things. Also, I have some good news. Let me show you. The good news will come up just as this pops up here. Just give it a minute. Well, I've done it, everybody. I've actually done it. I've collected all of the Pokemon. I've captured every single one. All 1,015 of them. Wait. That doesn't seem right, does it? 1,015? That can't be how many Pokemon there are. Is that right? Wow. Wait, really? There are currently 1,015 known species. Amazing. That's a lot more than I remember. 1,000. Well, okay. I guess that's great. I guess we'll just save that here to my database. That took a while to save all that. 24 seconds and some change. Wow, that's quite slow. Let's just write that down so we remember later. Seconds for 1,015. That is really quite slow. See, I'm saving this to Neo4j. Here's the code here that I'm using to save Mark. Mark is just the object that I built, the trainer object that I built. And it took a really long time. What if we just, for funsies, maybe, what would happen if we just made it a little bigger? What if we had 4,000 Pokemon instead? How long will that take, do you think? Let's find out. Okay, well, this will start up here in a second now. There's some pre-steps involved in knitting the trainer for you. You'll see some stuff printed out, and then it will do the actual save, where we capture the time for that. And, I don't know if you see, my glass of water here is empty, and I'm getting a little thirsty, so I'm gonna go get a glass of water. Yep, nice refreshing water. Ah, this must be done by now, right? It's not. Okay, wow. That is really quite slow. Uh, wow. That is really quite slow. So what went wrong? Well, so what our application is doing, as you saw briefly there, is that we are inserting many nodes and relationships into our Neo4j database. And we're using a library. We're using a library called Spring Data Neo4j, or SDN for short. And it's an object graph mapper, or OGM. And what SDN wants to do is it wants to synchronize state between the database and the object graph. So you'll kind of see that here. Well, I guess I'll let it finish running, and then we'll have to look at it. And so when that happens, it ends up with a bunch of like redundant inserts and lookups, because it wants the object, once the save is completed, to have everything that the database has and vice versa. But the problem is, though, is that SDN is not inserting child nodes in batches. And I encountered this actually recently as late last year or mid to late last year. This issue, and the issue is actually with the SDN library itself. The issue is still open as of right now. Here it is. There's actually multiple issues open on them, all the same, complaining about the same issue, that performance of this library tanks when you get to try and save so many nodes and relationships. Let's see if it's done now. Oh, it is. Wow, okay. So to do that 4,000 Pokemon, it took 96 seconds. Let's write that down so we remember. Oops. 4,000. About 4 times as much. It took almost 4 times as long. So what's going on? What if let's go back to what we had before, just so it's a little faster. When I encounter an issue like this, I like to print out the database statements. Let's do that so we can see what our friend here is doing. I'm just gonna shut this door real quick. Sorry about that. It's still a little cold over here in Minnesota, and shut the door so I can say it's nice and warm. Okay. Whew. There are a lot of statements being printed out right now. Oh Lord, wow, there really is a lot. Look at my scroll wheel. It just keeps on going. Just keeps on going. Let's scroll down and just take a look at like some of them. Make this a little bigger. Okay, so it's execute. Oh, uh-oh, went back up. I wish it would stop scrolling. I think there's a way to stop it from scrolling. Nope. Okay, looks like it stopped here. All right. No, it didn't. So look, we executed thousands and thousands and thousands of statements. Look at this. Let's just try and read this together, okay? Unwind $, underscore, underscore relationships, underscore, underscore as relationship with relationship. Relationship with relationship, that's confusing. Match, start node, et cetera, match, end node, relationship, merge, return. And then down at the bottom here, you have ID rel props as in underscore, underscore internal Neo4j ID underscore, underscore. This is a disaster. I have no idea what's going on here. These are not exactly what I would call easy to read, understand database statements. And not only that, it's doing thousands of them. So why is it doing thousands of them again? It's because it's not batching inserts of child nodes. What do we mean by child nodes? I'll show you. Here is what our data model looks like that we just saved. The circles are nodes in Neo4j. The arrows are relationships. And those nodes and relationships are the two data types that Neo4j has. In addition, nodes and relationships can have properties on them. So when we save our trainer, we are also saving all the items attached to the trainer, the PC, Pokédex, the Pokemon, and that PC is saving the box, which is saving all the Pokemon attached to it, which is saving all the stats and the moves, etc. And all those relationships, all in one operation. But when one trainer is saved, it then saves the child nodes Pokemon. It won't save these as a batch. It'll save them individually. And that is the crux of the issue that is open on the library right now. Okay, we got to talk about Neo4j a little bit, okay? Neo4j is a NoSQL database, and it's designed for highly connected data or graph data, nodes, edges, which are the relationships and properties. And it boasts having high performance when managing and querying highly connected data. That's what Neo4j is good at. It's good at being able to traverse those relationships quickly. So for instance, let's say in a relational database, you have a whole bunch of joins. Well, that's going to be a lot less performant than a Neo4j database where those instead of joins between tables, you have relationships between nodes. The core database engine and the query language for Neo4j is open source. And it has a healthy community, but it's not as robust as some others you may be used to. But there is a community out there. However, Neo4j is also a corporation, and they have enterprise exclusive features and an enterprise edition. And in the enterprise edition, they have pretty good support. It's well suited for certain use cases, such as recommendation engines, fraud detection, knowledge graphs, tracing, social networking, and others. Anything where there's a lot of highly connected data. It also has a handy desktop app. We could actually take a quick look at that. Here's the desktop app. You can create databases. You could connect your database. You could query. So I could do something like match T trainer. Oops, not trailer, trainer. Do has on. Oh, look, it even has auto completion. That's handy. Oops, P Pokemon, and then I will return all T's and P's. Returning T's and P's, what does that mean? Take a look. I'm not returning rows or documents. I'm returning subgraphs. So I'm returning the subgraph of the trainer mark and all the Pokemon who has this particular relationship between them. This UI also has some handy other features like this. You can do this. And that's kind of cool to see all your stuff. Kind of move it around, you know. You can do something like this too. That's a pretty handy little tool. And of course, what you saw me typing in that statement bar was Cypher. Cypher is Neo4j's query language. It has a unique syntax that works well with graphs. You think of it as like SQL for the graph. And a funny thing that makes me laugh is that they actually named it after this guy from the Matrix. This guy, if you remember, he betrays the party. He's one of the bad guys. So they named their query language after the bad guy who betrays them. I just think that's funny because They could name it Morpheus or Trinity or, one of the other good guys, but they went with the bad guy. We are going to be looking at a lot of Cypher in this presentation, so we have to go over how Cypher works. Consider this statement right here. Match trainer. Well, here's how I read this, okay? Match trainer nodes that have has-on team relationships with Pokemon, that have holding relationships with items called berries, where the trainer's name is Mark, and then return the Pokemon's nicknames. So let's break that down. Match T trainer. When it's in parens, it refers to nodes. So it matches any nodes with label trainer. Nodes don't have to have labels. They almost always do. They don't have to. Has on team. Let's look at this part. The square brackets refer to relationships. An arrow indicates direction. So this will match any relationship with a label has on team. Now, if we connect the first portion of this, excuse me. So this will match all trainer and Pokemon nodes that have a has on team relationship. And by that, I mean, it's not matching documents, it's not matching rows, it's matching the subgraph of all trainer and Pokemon nodes with that particular relationship between them. Think about it as subgraphs. There's a where clause, just like a where clause in like SQL. Filters results for query for trainer nodes with the name property equals to Mark. So t.name refers to a property. Item, name berry. The squiggly brackets with name berry, that's equivalent to the where statement. It's just a different syntax for doing it. This will filter all nodes with the name property berry. So if you put the whole first part together, we're now matching the entire subgraph from trainer to item, which includes Pokemon in the middle, and with these two relationships. And the last part is the simplest. You can return nodes, relationships, or properties. So this one is actually returning a property. It's returning the property of nickname of Pokemon. So if we were to run this against a database with a bunch of Pokemon in it, we would get an array of strings. Because we're returning properties, we're not returning nodes or relationships. Okay, we talked about Neo4j a little bit. We talked about its query language. Now we have to think about the other tool that we're using, Spring Data Neo4j. As we mentioned, it's an object graph mapper. And in 2020, they released version 6 called SDN6. SDN5, however, the previous version, used Neo4j OGM as underlying mapper. That's because Spring Data, it's more like an interface, and then different libraries can implement it. And so when they released Spring 5 or SDN 5 and before, they used Neo4j OGM, which is independent OGM, as the implementation of SDN. But in SDN 6, they ditched that OGM library in preference for their own implementation. That was in 2020. And we noted that our performance issues exist in SDN 6. They did not exist in SDN 5. And I discovered this issue when my team upgraded our Spring Boot version. Because when we upgraded our Spring Boot version, we got the latest version of SDN, which is SDN 6. And even though we had to do some migration, their migration docs didn't mention any potential performance hits. So when we tested it against larger objects, we found that our performance plummeted, just like it did in our demo that we just saw. And I'll note again that this is because SDN and OGM, they both do this. They synchronize state between the database and the model, but OGM does it much more performantly for large graphs. And the SDN team is still working on this at the time of writing. This issue is the one that we looked at before. when I talked to them about this, I actually was working with a client that had enterprise support with Neo4j. And even though SDN is its own library, the developers on it also work for Neo4j. So I was able to get onto a call with them. And when at first they were like, well, we don't really believe there's a performance issue. You haven't really provided any evidence to us. We provided them the evidence. And then they were like, okay, well, we think it's happening because of this batching issue, but we are not going to fix it soon, if ever. That's what they told me then. That was probably sometime last year. Since then, they have acknowledged the issue, and as we saw, they have like 4 or 5 issues open on them. So they're working on it now. At the time, though, we were kind of left without a paddle. Okay, so I noted that this is a object graph mapper. Object graph mappers share a lot of similarities, a lot of the same benefits, and a lot of the same problems as object relational mappers that you're probably used to working in other with relational databases or with other systems. So we have to talk about object relational mappers a little bit. So what are they, real quick? So object relational mappers, or ORMs, are database toolkits that enable developers to interact with their database in an object-oriented way. And there has been a lot of discussion about the benefits and the problems of ORMs. In fact, it's been called the Vietnam of computer science. I find that to be a little silly. Vietnam referring to the Vietnam War, the US Vietnam War. I think that's a little hyperbolic, but the point is that there are a lot of disagreements about whether they're good, bad, what they're good at, what they're bad at, and people who just want to ditch ORMs altogether. With that said, though, there are many very popular and well-supported ORMs out there for almost any technology stack. Hibernate, Django ORM, Active Record, Entity Framework, and SQLize are just to name a few. And even though there are a lot of complaints about ORMs, they actually do offer a large variety of features and benefits. And for our purposes, we could group them into 4. 1, they abstract away boilerplate. They can help you prevent, by that, I'm kind of grouping a bunch of different things, but essentially it means that they can prevent common errors like SQL injection. They help with transaction management, query generation, and more features that I'd sort of group into abstract away boilerplate. Many ORMs offer caching, which is nice. Some people call caching the Vietnam of computer science. It's a hard topic, and the way that ORMs can integrate that into their system can be beneficial. Database portability. This is a big one. Because it's abstracting between the database and your programming language, it allows you to be able to switch databases without having to change your code. And last, the mapping and synchronization between databases and object-oriented programming. So that is what we saw in our example, where it's doing so many different statements. Well, the reason why it's doing all of that is because not only is it traversing the object and then turning that into an insert on the database side, it's also fetching the latest state from the database and then serializing that back into the object. This is a feature that all ORMs more or less have. So with that said, ORMs have been around a long time. And the kind of systems that we're building have changed a lot over time. And in order to really grasp how they fit into modern architectures, we have to think about a concept called domain-driven design. Wait, just wait. Don't log off yet. Don't turn off the meeting. This is not a trick. This is not going to become a domain-driven design talk. I just need to mention it because it's relevant to our discussion about ORMs. Okay, still with me? Great. Whew. Sometimes domain-driven design loses people. By domain-driven design, I'm talking about the seminal book on the topic, Domain-Driven Design by Eric Evans. And this is one I read recently that I think is a better intro than most others out there. which is Learning Domain-Driven Design by Vlad Konikov. Okay, the reason why I bring this up though is because ORMs and domain-driven design are a perfect match. The reason why is because domain-driven design by Eric Evans teaches us to model our business domains, like the picture on the right here. Object-oriented programming and relational databases are very powerful tools for being able to model or implement those designs. So for example, consider this diagram again. This is representative of the kind of business domains we were building at the time that the Eric Evans book was published. And it doesn't take a whole lot of imagination to imagine how you would build the same system in either an object-oriented programming language or in a relational database. So it's not an accident, though, that ORMs are a really elegant way to bind object-oriented programming and databases together. And both those things can represent these kind of business domains really well. So the synergy is natural. You have a design like this, you could build that very elegantly in object-oriented programming and in your relational database, and use ORMs to tie it all together. You have a really nice, neat application that works well. You'll also notice that I don't know the exact history of the concepts behind domain-driven design or ORMs. I do notice, though, that they share a lot of similar terminology and concepts: entities, value objects, repositories. You'll see those kind of terms in both paradigms. However, here's the thing. These are the kind of business domains we were building at the time that book was published. But now we're building different kinds of domains. You might say higher level domains, microservices, event-driven architectures, CQRS-based systems. And my point is that the benefits of ORM are less important in these kind of architectures. So let's talk about why. So we noted the four benefits of ORMs. Number 3 was database portability. Database portability, I think that we don't really have to argue much that it's inherently useful. But the thing is, though, in our distributed type architectures, we could be using different storage technologies for different purposes. And in fact, every microservice that we have might be using a different database. So therefore, the business is not reliant on a specific storage technology. For example, there isn't as much worry about being locked into Oracle, for example. The point is that database portability is not as critical as often. The other thing, though, the fourth thing about ORMs that we noted is the mapping and synchronization aspect of them. See, the thing is, though, is that our domains aren't comprised of things that are easily modeled by object-oriented programming or by databases. Instead, they're things that are better modeled by services, clusters, APIs, as a service, et cetera, or maybe streams of events. Or maybe they have, in like a CQRS type situation, separate read and write models. So the point here is that you have a lot less need for that synchronization aspect because every operation is only ever reading or it's only ever writing. It's not writing, getting the latest state, and then doing something else. So in this case, we don't really, in those sorts of architectures, we don't need this mapping synchronization aspect of ORMs. Okay, so with that said, last note, ORMs are still useful in modern architecture. I'm not saying that they're not useful. I'm just saying it's not as clear that you need all the benefits as often. So with that note, I'm going to let you chew on the ORM aspect of this, and we are going to fix the problem with our ORM that we saw earlier. First, quick recommendation for this book, Neo4j High Performance by Sonal Raj. I actually recommend that you read this book before you commit to any particular data model. The reason why is because a good portion of this book is actually just talking about how do you design your graph in such a way that it lends to performant queries. That's something that I wish I had the chance to do on my last client project. Another thing this book does well is it gets into the administrative side, Neo4j Enterprise Edition, and I don't know if it's just Enterprise Edition or Enterprise and Core, but there's server-side caching options as well. Okay. Let's talk about the solution that we're going to build. Okay. And it will involve two tricks. The first will be to utilize custom indexes. So take a look at this little subgraph here. So node internal IDs, or sorry, nodes have internal IDs. So the trainer and Pokemon, they'll have internal IDs, and those are indexed by default. But trying to use those for large inserts is problematic. Here's why. If I want to create this graph, I have to first insert trainer Mark, and then I have to insert Pokemon Bob, and then I need to get their IDs that are generated on the insert. And then I need to use them to create the has-on team relationship. Okay. Well, what we want to do is we want to just insert them all at once. So to do that, what we'll do is we'll create a UUID property on all three of these objects, and we'll create custom index on that UUID property. And then with that UUID property, that'll allow us to insert these objects as batches. And we're going to use something called Neo4j's Awesome Procedures on Cypher, or APOC, to help us with this. So by inserting batches, here's what I mean. What we'll do is we'll take our nodes and relationships and we'll serialize them into an array, a flat array of JSON objects. So we'll take that really complex graph that we looked at before. We'll squish it down into a linear array. We'll serialize the objects as JSON. We'll break that JSON array into batches. Then finally, we'll use APOC to insert that batch into the database. Let's see it. And we're doing good on time. Excellent. Okay, so take a look at this. This is our standard Spring data repository. Extends Neo4j repository. But then also we have this trainer custom repository and trainer custom repository. Oh, my bad. Has a save trainer method on it. We'll take a look at the implementation of that. So the top level, so this is going to be our more performant insert. Okay, we're going to insert the entire trainer. And trainer, by the way, it is a model, a node, and it has some properties, and then it has its relationships to other models like Pokemon, items, Pokédex, PC. And you can imagine, if you remember what that diagram looked like. PC then will have boxes and items, and a box will have other things in it, Pokemon, and Pokemon have moves, stats, etc. So it's a bunch of objects and a big graph between them, right? So the first thing we're actually going to do just 3 steps here. We're going to prepare our input. We're going to upsert the trainer, and then we will delete any detached nodes. By detached, that means nodes that have been orphaned because, let's say, we switched a relationship from one node to another node. So let's look at prepare input. For prepare input, there's actually quite a lot of code here, but it's relatively simple. What we're doing is we're taking a trainer and we're going to convert it into a trainer input. What is a trainer input? A trainer input is just like we talked about before. It's going to just have lists of objects. And all this is for is to make it easy to serialize this to JSON later. So all this is the trainer node, it'll just have just the properties. It won't have any of the relationships because we're going to break that up, right? In addition, we also have input for all the relationships as well. Relationship is pretty simple. It's just source node and a target node. So with trainer input, we can serialize those arrays to JSON a lot easier. There's quite a lot of code here to make this happen because there are a lot of objects and a lot of properties. Now let's take a look at the main event, upserting. Okay, so here's the upsert. So the first thing you'll notice is that you have some very similar looking statements, execute with JSON, and then we pass the query, and then we pass the input. And we do that for every single node type. And we do this for every single relationship type. We don't need to do this. We don't need to look at every one of these queries. We'll just look at one that's pretty representative. Let's look at Pokemon. Let me give you a little more space here. So here's the insert query for Pokemon nodes. The first thing is we'll use APOC to convert our JSON input, which is what $ input meant to be a parameterized input, as input. So it's deserializing it from JSON, or sorry, serializing from JSON into however Neo4j stores objects internally. I don't know exactly how that is. Next statement, unwind. We actually saw unwind earlier when we were looking at what SDN was doing. So unwind is like for each. So it's saying for each element of input, execute the following as Pokemon node. So then finally it's merge. This will execute for every element and input. Merge is insert or update. So what it's going to do is it's going to look for the Pokemon node with this matching UUID. If it finds it, it will update the properties with the properties that are set in Pokemon node. If it doesn't find it, then it will just insert the Pokemon node with these properties. So pretty simple, right? So where's the batching come in? Well, we have one giant array of Pokemon here, but then when we call the execute with JSON, we break that list into batches of batch size, and then we just run the it's called a query, but it's actually an insert statement. We run this query. If we bind this, we serialize it as JSON, bind it, and that will be the $ input field that we saw. Okay, if we look at another one, let's say Pokédex, that's very similar. It just you have Pokédex instead of Pokemon. You might ask, can't you squish this down a little bit? You know, since they're all the same, just with a different type, can't you just parameterize that type? And the answer is yes, you can. I didn't do that for demonstrative purposes because I find that it would be hard to understand what's going on if I also parameterize these types. But no, you can do that. You can do that. The same thing we did with nodes, we do with relationships, where we insert each different type of relationship separately. Let's look at has-move relationship. First thing, very similar to what we saw before. We use APOC to take this JSON and serialize it into our Neo4j object. We then unwind, and for every element, we're going to match the start node, match the target node, excuse me, and then we will merge the has-move relationship. And merge again, we're just going to either update that relationship or create it. Now, this relationship doesn't have any properties on it, so updating it doesn't really do anything. But there are relationships with properties that you can update, like this one, for example. So it's very similar to what we saw before with the nodes. And so that's it. We're just inserting these as batches. There's no more code here. Well, there's the delete detached, but that's not important for our purposes here. That's just important in practice. Let's actually see this run now. Get to the fun part. Oh, I promised to show you the indexes again, we have a UUID field on each of those nodes and relationships. And we will write on each of these nodes. And we create an index on them on n.uuid. And do that for all the node types. They're pretty simple. So noted that it took like almost 100 seconds to execute that 4,000. And let's go back to the 4,000. I believe it was like this, and like that. And now we'll execute our more performant version. This is very similar to the other test. We created the trainer named Ash, and we'll save the trainer named Ash with our new function. There's some setup stuff that'll take a little longer, but oh, I'm sorry. I don't want to print all that stuff out again. There, that's better. Let's give this a few seconds. There's some initial setup here that is always a little slower. Okay, but it did complete in 14 seconds. So 14 seconds for 4,000. That is a massive improvement over our friend, even at 1,000, it's faster. And it's way faster than the 4,000. I mean, that's a massive, massive difference. You might note though that it's still not like amazingly, blazingly fast. Let me show you what I mean. Let's see, let me just commit this. I have a handy branch here where I rebuilt this in Postgres. I mean, it's not exactly the same, but it's pretty close of being an equivalent data model. Let's see, Gradle is being a little slow on me. Should be better. So what if we ran the Postgres version? So the Postgres version ran in about 8 seconds, almost 9 seconds. So again, it's not blazingly fast compared to, let's say, Postgres. But I think that's because Neo4j is not optimized for inserts, it's optimized for reading. Also, there are some things server side that I'm just not doing. I'm running a default configuration of Neo4j. However, with our improvements, we still got a massive improvement over the SDN library. Okay, we have one more thing that we have to talk about. I want to circle back to ORMs, but before I do that, are there any questions on the solution that we just looked at here?
I'm not seeing any questions in the question and answer, but if anyone wants to type one in quickly, please do so.
I'll give them another few seconds to type in the question. All right. Well, hopefully that made sense. I hope that the solution is simple enough and communicatable enough that you'll be able to understand. I want to note that there are some alternative solutions to this issue. One is called projections. This is a feature offered by SDN library. And it's useful for saving partial graphs. What you could do is you could say, I only want to save Pokemon and the Pokemon on that trainer's team. Or sorry, the trainer and the Pokemon on that trainer's team. So that lets you limit how many nodes that you touch with your updates at once. The problem though is that large projections still have the same performance issue. So much so that in fact, the ticket that we looked at that's open on the SDN library uses projections. So again, useful for being able to save partial graphs, but if that partial graph itself is very large, you'll have a problem. The other thing you could do is you can actually use the old Neo4j OGM library that was included with SDN5. There's like a, I don't know if you call it a backport, but there's a way to configure Spring such that you can use that. There's an example linked here. And OGM had much better performance, probably on par with, or maybe slightly worse than the solution that we built. Okay, with that said, like I said, I want to circle back to ORMs. So what do we do about ORMs? After I had this issue and after I fixed this issue, I was ready to swear off ORMs forever. I was like, they're too bloated, they're too slow, they have too many bugs, et cetera, et cetera, et cetera. In fact, actually, it's not the first time that I've said that in my career. When I really looked into it, I realized that that instinct is probably not well thought out. Because here's the thing. An ORM is not a replacement for understanding the underlying database. If you want to use ORMs effectively, it's better to understand the database technology that you're using than it is to understand the ORM tool. Because if you understand the database technology that you're using, you'll be able to make better decisions about your ORM. Another thing is that you need to understand your business domain thoroughly. We noted that there's a shared language between ORMs and domain-driven design, and that the two are both deeply ingrained in enterprise software. So if you're going to use ORMs effectively, you need to understand your business domain. By doing these two things, you'll be able to use your ORM more intelligently because you'll be able to figure out which cases you need to write raw queries like we did for our solution just now, and cases where the ORM can really help you out by saving you from having to write a lot of code or with errors or with caching. The thing is, this advice, while well conceived, doesn't scale well. This is good advice, don't get me wrong. You should be doing these two things anyway, regardless, but it doesn't scale well. What do I mean by it doesn't scale well? As your development team gets larger, you're going to have people with a variety of different experience levels, backgrounds, etc. And keeping all these people informed on these two topics As your development team gets larger and your application gets larger, that's going to be a lot harder to do. Manageable, but harder to do. The other thing is that our technology is changing all the time. New storage technologies are coming out all the time. New ORMs are coming out all the time. In fact, this issue that we had is partially to blame because of a change in our technology that we were using. And the last thing is that as important as domain-driven design is, and understanding your business domains is, domain-driven design is a campaign. It's not something you could just sit down with a business analyst and figure it out in a meeting. It could take multiple meetings, multiple weeks, multiple different meetings with different people. It's a long campaign that you have to go on. And you should go on it, but you have to go on it. So what practical advice would I give to somebody who, let's say, you're watching this presentation and you're working right now on your laptop because you have a deadline due next week? Well, giving you this advice here, while it's good advice, is not going to help you with a deadline you have next week. It's not going to help you on a project that has been around for a long time and you have to fix some bug or add some new feature or et cetera. So what advice can I give to somebody that's a little bit more practical? Well, that's where we come up with the idea of the micro-ORM. So alternative database toolkits are available. They call themselves micro-ORMs, SQL wrappers, query builders, and they offer a subset of the benefits of ORMs. Usually, I mean, they have a wide variety of different features, but usually they're implemented as lightweight wrappers around the query language. Sometimes there's some rudimentary object mapping. And the first thing that they usually ditch is the synchronization. Synchronization between the objects and the database. And the synchronization played into our issue. We were paying a lot of overhead for that. And a lot of these tools will ditch that aspect of it. Some examples of this include Dapper, SQLite, ORM Lite, SQL for Ruby, and SQL-C. If I were working on a new project right now, I would probably start with SQLite, unless I know for sure that I need those 4 aspects of ORM in my for my solution. And that's it. That's my presentation. Any parting questions?
At this time, there are no questions in Q&A.
How many people do we have on?
I'm not able to see how many are in the web
Oh.
client, but in the actual Zoom client itself, we've had I think the peak was about 20 people.
Okay, not bad, not bad. I do have the project on GitHub. I'm actually going to share a link for that right at the end here.
We do have one comment that it was a really neat problem to solve. Thank you for that feedback.
Thank you. Well, let me get that link for you. This will be a read only. Let's make it. Huh, okay. Well, download this soon then, if you want this. And let's see, I believe if I go here and type to everyone, you should be able to see this, right?
I'm seeing that in chat, yes. And we have another thank you.
Okay, thanks for calling in.
Anyone else with comments? Give you a few more moments.
Yeah, I guess if I were to summarize my parting advice for those of you out there is consider these 4 aspects of ORMs: the abstract and the caching, the portability, and the synchronization. And think about how you need that in relation to your business need. And also just make sure you understand how your database technology works. If you don't know for sure that you need to use it, consider a micro-ORM. Oh, and check out this book before you commit to your Neo4j data model.
All righty, with no other questions or comments, I want to thank you all for attending Improving Talks. Next week, we will be having a panel discussion, why a product vision is critical to inspire change. Landon from First United Bank will be discussing their spend wisely decisions, how United Bank is encouraging communities to connect, experience life together, and belong. Hope to see you all there next week. Same link. We'll see you then.
All right, thank you, everybody. Have a good day.